So 4.4, the name of the subtopic is reactions in organic chemistry. So from this subtopic, awak akan diberi pendedahan berkaitan what kind of reactions. Okay, so we have these reactions. You are going to learn about so many reactions, but then awak kena faham, we have types and names. They are not the same. Type of reactions tak sama dengan name of reaction. Okay, saya nak ulang dulu ni. Type of reactions is not the same as in name of reaction. Type of reaction, apa yang awak buat. Contoh, you buat addition. That's the type of reaction. But if let's say, the reactions given is halogenation. Halogenation is not type of reaction. It's the name of reactions. Means halogen being added. Macam tu. Okay, faham ke? Awak akan jumpa banyak tapi bukan semua benda adalah type of reaction. Jadi dalam subtopik ni kita akan belajar pasal type of reactions.
Okay, Miss.
Alright, so starter pack dalam organic chemistry, you are going to learn about this whole thing and you're going to keep on repeating the same thing lah, tapi with different class of compound. Okay, so the first one, you need to know these two types of covalent bond cleavage. Okay, bila kita kata bond cleavage, maksudnya akan melibatkan bond breaking. So the bond breaking, we have two types. One is homolytic, another one is heterolytic. Homo means between the same atom, hetero means between the different atoms. And apart from bond cleavage, after you have done the bond cleavage, from the homolytic cleavage, where's my pointer? From this homolytic cleavage, sebab dia same, dia akan hasilkan free radicals. So this is basically 3 intermediate species comes from the bond cleavage in here. From homolytic, you are going to form free radicals. From heterolytics, because they comes from 2 different atoms, once the bond is cleaved, you are going to get either cation or anion. But since we are dealing with organic compounds, your intermediate species will deal with carbon. That's why cation with carbon, carbon with cation on it, we call it as carbocation. Carbon with positive charge. Carbon and negative charge, we call them as carboanions. Okay, having this intermediate species, then we need to determine whether these species or any other species will be the nucleophile or electrophile. So this basically the 2 terms that is very important whenever you want to make reactions. Who's gonna attack? Who's gonna be attacked? Tu kita panggil dia nucleophile or electrophile. This reagent means, kan kalau kita buat eksperimen ke apa, kita kan melibatkan reagent kan dalam bentuk solutions ke, betul tak?
Betul.
So reagent awak ni lah yang akan yang kiranya basically the carbocation, carboanion free radicals ni comes from the reagent jugalah, sebab tu lah nucleophile and electrophile comes under reagent. So reagent jugalah yang akan kita guna dalam satu reactions tu nak menentukan siapa yang akan jadi reactant, dan when they react they will become the product. Okay, knowing this reagent, each of this reagent will form this intermediate species. From the intermediate species, we get to know which side is prone to nucleophile, which side is prone to electrophile. Okay, so selain pada nucleophile and electrophile adalah species. Bila kita nak tengok reactivity dia, siapa yang akan attack, siapa akan tak, kita panggil nucleophilic site. So they are not the same. Kalau awak tulis nucleophile site, salah. Kalau nak kata pasal site, kena nucleophilic site. Kalau electrophile is a species. Electrophilic site adalah site di mana yang dia prone to electrophile. Electrophile boleh masuk dekat situ. And lastly, type of reactions. So this is type of reactions yang awak ada, hanya 4 sahaja. Tetapi kalau kita to be specific, in additions we have 2 types of reactions pula. Kenapa ada 2? Sebab we are dealing with this intermediate species. So maybe in addition, silap yang ni, this one. Kalau yang additions kita ada 2, nucleophilic addition, electrophilic addition. Elimination dia melibatkan awak nak buang bond. So dia tak adalah nucleophile dengan electrophile, dia simply buang. Substitutions, daripada 1 kita akan pecah jadi 3. Nucleophilic substitution, electrophilic substitutions and free radical substitutions. And lastly, rearrangement, you have this one structure. By not adding or eliminating or substituting anything, you're going to rearrange them. Maksudnya, samalah macam case, contoh kita ada functional group isomer, they have the same general formula. Rearrangement ni berlaku pada same general formula jugalah. Contoh daripada aldehyde, awak nak jadikan dia ketone. masih ada molecular formula yang sama. Tetapi bila dia rearrange under certain conditions, dia akan jadi different things. Okay, itu je lah yang basically untuk 4.4 ni yang kita nak belajar hari ni. So we'll start with the bond cleavage. So this homolytic cleavage means the cleavage occurs in a non-polar bond. Kita dah belajar non-polar bond ni dia melibatkan atoms yang
Inert.
atoms yang inert.
Sama.
Yang
Sama.
Inert dengan sama, maksud dia sama ke? Terkejut lah, saya first time
Tak
dengar.
sama.
Tak sama. Inert group 18 awak. Tolong jangan buat saya terkejut. Okay. Non-polar bond, you ada same atoms. Tak kisahlah carbon dengan carbon ke, Cl dengan Cl ke. Bila dia sama, kita panggil dia non-polar bond. Bila non-polar bond, we want to cleave them, they are going to undergo this homolytic cleavage. Homolytic cleavage ni, when you have this non-polar bond, involving equal sharing. Sebab diorang sama, kalau dia pecah pun akan dapat sama banyak. Okay, tapi make sure diorang ni kena sama dahulu. Okay, how is this equal sharing happen? Okay, so with the presence of light or UV or HV, bila kita kata homolytic cleavage, bila ada sama atoms kat sini, kena ada these conditions. Why? Because chlorine and carbon and carbon, when they have same electronegativity, it is very difficult for you to simply break them. Okay, jadi diperlukan satu lagi tenaga yang kuat dari luar. So selalunya datang pada haba lah. Daripada light, lampu, daripada UV pun lampu juga, HV pun lampu. Tak kisahlah mana-mana salah satu, kena ada the presence of light. Tak ada presence of light, the homolytic cleavage won't happen. Okay?
Okay.
Okay. So basically, this bond Cl and Cl or any other similar electronegativity punya atoms, they are going to break symmetrically into two equal parts. Bila break symmetrically, kita kata dia dapat sama banyak, kita akan guna arrow, half-headed arrow. We know in each bond we have 2 electrons. Means if they are going to break symmetrically, each chlorine will get 1 electrons. Sebab tu dia kata into 2 equal parts. Okay, bila dia ada dah jadi 2 equal parts, last sekali, leaving them with 1 atom with 1 unpaired electrons. So basically kita tahu Cl ni kan keliling dia ada lagi 6 kan? Kita ada 1, 2, 3, 4, 5, 6, right? Ni pun 1, 2, 3, 4, 5, 6. Betul tak? Ya Allah, hudunya. Ada 6 kan? Tapi bila dia dapat 1, dia jadi dah 7 macam ni. Kiranya dia octet tak Cl ni? Kalau dia ada 1 unpaired electron saja yang dia terima? Jadi octet tak Cl yang kita dapat ni kat belah kanan ni? Octet tak? Cuba kira. Tak tahu ke maksud octet tu apa? No, they are not octet.
Octet,
Right?
Miss.
Are they octet
Yes,
or not?
not octet.
Not octet. So bila dia not octet, kita tak boleh kata dia stabil lah. Kalau dia tak octet means dia tak stabil. Sebab itulah dia akan form this species called free radicals. Free radicals is when you have 1 unpaired electron. So your 1 unpaired electrons comes from the homolytic cleavage. The homolytic cleavage require light or UV or HV to rescue untuk dapatkan this reaction. Kalau tak ada light, UV or HV, dia tak boleh buat reactions. Okay, itu adalah homolytic cleavage. Homolytic cleavage form free radicals. Okay, and then we have heterolytic cleavage. It's the opposite to homolytic cleavage where they are going to involve polar bond. So bila kita kata polar bond, maksudnya atom awak sama ke lain?
Lain.
So sebab itulah kita ada polar bond. So this polar bond now, since they are not the same, they will involve unequal sharing of electron pair between 2 atoms of different electronegativities. Maksudnya tadi kita break symmetrically. Kalau dia lain, dia akan break symmetrically or break asymmetrically.
Symmetrically.
Yang homolytic ke?
Hetero.
Oh, hetero. Hetero unsymmetrically.
Okay, unsymmetrically lah. Okay, jadi bila dia breaks nanti dia akan unsymmetrically. Okay, tapi sebelum tu macam mana kita nak tahu dia nak breaks, nak bagi kepada siapa? Macam homolytic tadi, kita akan bagi sama banyak. So tak kisahlah, dua-dua pun akan dapat sama banyak. Tetapi dalam heterolytic cleavage, bila kita breaks the electron, breaks the bond, maksudnya kita akan bagi elektron kan? Ni bond ni kita dah tak nak dah antara dia orang. Jadi kita akan pecahkan dia, betul tak?
Betul.
Kawan awak cakap tadi breaks asymmetrically, tak sama. Okay, sekarang ni bila kita pecahkan, elektron sama ada akan diberi semua kepada satu atom ataupun dan satu lagi atom takkan dapat apa-apa. So, bila awak nak tentukan siapa yang akan dapat atom, kita akan tengok electronegativity of each atom tu. Okay, what do you think? The electrons will be pulled towards partially negative or partially positive atom? Elektron akan bergerak ke arah siapa? Yang partially positive ke partially negative? Stronger pull or weaker pull for electrons?
Stronger pull.
Yeah, stronger pull. Stronger pull for electrons dominated by the partially negative atom. Jadi dalam kes yang pertama kita ada Cl. Jadi this whole bond daripada dua elektron tadi kita akan bagi dua-dua elektron kepada Cl minus. Yang carbon dan Cl, sebab Cl is partially negative, kita akan bagi semua elektron dekat Cl. So what will happen to this Cl when they received all the electrons? They become electron rich or electron deficient?
Rich. Electron rich.
Okay, electron rich boleh terima banyak. So bila dia breaks ni, kita tahu bila semua dapat kat dia electron rich. Electron rich kita denote sebagai negative charge, betul tak?
Betul.
Okay, maksudnya hydrogen akan jadi negative or positive charge?
Positive.
Positive. So bila
Positive.
bila bond ni dia breaks asymmetrically, dia akan dapat two different parts. One is called electron diffusion species ataupun selalunya kita panggil dia cation. So dalam cation dalam kes kita sekarang, kalau awak ada hydrogen, kita panggil dia cation biasalah. Tetapi kalau awak punya cation melibatkan carbon, kita akan panggil dia carbocation. Okay?
Okay.
Okay, another species to be formed. Kalau ini electron diffusion, maksudnya lagi satu elektron apa? Electron diffusion ni miskin. Kalau satu lagi kaya, kita panggil apa?
Rich.
Electron rich. Electron rich, kalau tadi cation, sekarang electron rich kita siapa?
Anion.
Anion.
Yeah.
Anion. Yes, anion for both case adalah
Cl.
ya, Cl minus. Okay, faham ke macam mana heterolytic ni kita buat? Kenapa dia pergi dekat Cl instead of hydrogen? Kenapa kita panggil carbocation instead of cation?
Faham.
Okay. Make sure when you do the cleavage, they must touch this bond. Kalau tergantung tak dikira. Okay. Bila kita kena denote positive, partially negative pun kena tunjuk supaya kita tahu dia prone to siapa, nak ke arah siapa. Every time awak nak buat reactions, reactivity, kena tunjuk ini dulu, barulah kita boleh buat the attack or being attacked. And then when we are dealing with chemical reactions, we have so many types of arrows. So before we go deeper into this SK025 course, kita kena tahu type of arrow yang kita akan jumpa. So if you have this kind of arrow, that simply means reactant to become product. And sometimes you have this arrow, kita dah pernah jumpa ni, they are in equilibrium. There are some reactions in SK025 that involves equilibrium. Lagi kita ada this arrow pun dah jumpa, resonance structure pun akan guna juga a few times in this semester. And then this one you already come across tadi kan, when you want to move a pair of electron, kita akan guna full headed arrow. Maksudnya semua elektron ke arah dia. And if you have this half-headed arrow, means they want to move only one single electrons. So yang ni kita jumpa dalam heterolytic tadi, ini kita jumpa dalam homolytic cleavage. Okay, next. When you have done the bond cleavage, means you are going to form this intermediate species. This intermediate species is very important for you to form them. Maksudnya kena tahu kita nak jadikan siapa supaya reaction seterusnya kita nak buat apa. Kalau awak dah pecahkan bond, awak tak tahu awak form free radical ke, awak form carbocation ke carbanion. Let's say the reactions continues, macam mana awak nak tahu awak nak buat apa lepas tu? So that's why we need to know the feature of this intermediate species. Dia ni rich or deficient. Okay, intermediate ni maksudnya dia ni dalam, dia bukan lagi final product. Dia pertengahan. You are in the middle of the reactions. Bila dia kata in the middle of reactions, dia masih belum stabil. Bila dia masih belum stabil, dia tak mungkin adalah neutral compound. Dia mesti dalam keadaan yang electron deficient or electron rich. Okay. So we're going to deal with these three intermediate species and kita akan tengok the relative stabilities one by one. So in here, what kind of cleavage do you think will happen? Kalau kita tengok C dengan C, C dengan H, diorang punya electronegativity lebih kurang sama ke jauh beza?
Sama.
Lebih kurang sama.
Lebih jarang.
Ya, lebih kurang sama. Bila lebih kurang sama, we want to go for homolytic or heterolytic?
Homolytic.
Kalau homolytic, kena dia akan break symmetrically or break asymmetrically? Symmetrically. So, in order for you to perform this homolytic cleavage, what kind of conditions that you need to add on? Maksudnya, conditions apa yang kena ada kalau homolytic cleavage tadi? Tak ada dia, tak boleh buat.
UV light.
UV light. So with the presence of UV light, the homolytic cleavage will happen. Sebenarnya homolytic cleavage boleh berlaku antara C dengan C dan juga C dengan H. Dia depends siapa final product awak ataupun apa reactions yang dia nak buat. Okay, now kita nak pecahkan this single bond between carbon and carbon, means we are going to form apa dia kat sini. Belah kanan ni kita akan form apa kalau you undergo homolytic cleavage?
Free radicals.
Yeah, free radicals with each unpaired electrons surrounds it. Jadi kalau radicals yang melibatkan carbon, kita panggil dia carbon radicals. Okay, carbon radicals ni dia tak achieve octet. Jadi dia termasuk dalam case electron deficient or electron rich. Electron deficient or
Electron division.
Ya, electron deficient because they are not octet. Dia hanya ada 7 je. 2, 4, 6, 7. Sepatutnya dia kena 8. Okay, the second species yang kita akan tengok melibatkan, now we have this polar bond. Okay, this polar bond, if let's say, this polar bond, kalau kita breaks dia macam ni, kita tengok antara carbon dengan Br, carbon is partially positive, Br is partially negative, means all the electrons will go to Br. What kind of intermediate species will be formed here? What kind of carbon will be formed on your right if you gives all the electrons on this bond to Br?
Cation anion.
Apa?
Cation and anion.
Okay, when you have positive charge on carbon, what do we call them?
Carbo and
Cation.
carbocation.
Carbocation dan juga kita akan dapat juga Br minus ni kiranya anion lah, awak pecahkan dia. Okay, so we have these two species. So we've got another one involving carbon juga. Kalau ada carbocations means ada juga carbo and ion. So carbo and ion, macam mana kita nak dapatkan dia? Okay, carbo and ion usually happen when you have another species that is electron rich. They're going to take your hydrogen or any other species lah yang kiranya dia ni kena kuat. Okay, kena kuat, dia akan ambil. Bila dia ambil, dia akan bagi semua elektron kepada carbon ni. Okay, nanti yang awak akan belajar lagi banyak lah dalam SEM ni. So bila semua elektron go to carbon, what will happen to this carbon? Are they going to form positive charge or negative charge if they receive the electrons?
Negative.
Positive or negative?
Negative.
Negative. So negative kita panggil dia
Anion.
carbanion. So carbanion, beza antara carbocation and carbanion apa benda selain charge. Bila you ada negative charge means they are electron apa?
Rich.
electron rich. Means suppose this carbon kan patutnya octet 8. So betul dia ada 8. Tetapi kalau tengok dia punya bilangan elektron 1, 2, 3, 4, 5. Maksudnya dia lebih lah. So maksudnya electron rich. Okay, carbon anion basically HBr. Kalau H ambil lah, kalau dia pecah sahaja, H sahaja dapat cation kat sebelah sini. So kita nak tengok relative stabilities for all three species. Carbon radical, carbocation and carboanion. Okay, so for the first one, relative stabilities of free radicals involving carbon. So these free radicals got 4 classes, okay? And 4 classes sebab apa? Kita belajar carbon kita kan kita ada sp3 hybridized tu kan. Lepas tu kita tahu carbon punya class ada sampai quaternary. But then we remove one of the bond and then we simply substitute with this radical. Okay, so we'll start from all of them adalah hydrogen. Kita tukar satu dengan alkyl group, 2 alkyl group, 3 alkyl group. Sebab tu dapat 4 classes. Okay, since radical carbon is an electron deficient species, jadi awak rasa electron deficient ni maksudnya dia kurang ke banyak elektron dekat carbon dia?
Kurang.
Bila dia kurang, untuk dia stabil, dia perlukan elektron yang lagi banyak ke dia tak perlu elektron kalau dia perlukan, dia nak stabilkan diri dia? At the moment they are positive, kita bayangkan dia positif lah, dia deficient of electron, but then kalau dia nak stabilkan diri dia require electron rich or electron deficient species?
Perlu electrons.
Ya, perlu electrons yang untuk stabilkan dia. Kiranya ini positif, yang datang ke arah dia tu kena negatif. So sekarang ni hidrogen, banyak ke elektron keliling hidrogen? Awak rasa hidrogen banyak tak elektron keliling dia? Tak banyak. Kalau ikutkan hidrogen kan satu. Kiranya ada 3 elektron je surrounds this carbon, right? Dia somehow boleh stabilize tapi sikit. Okay, what about this one? You have one alkyl group. You know what is meant by alkyl group kan?
Yes.
Okay, so alkyl group basically you have alkane but then they becomes the substituent. Maksudnya dia akan jadi macam at least CH3 lah. Okay, let's say your R now is CH3. Instead of having only 3 hydrogens surrounds the carbon radical, in here if you have one alkyl group comprises of CH3, how many hydrogen do you have that surrounds this carbon? Kita ada 1, 2, 3, 4 and 5, right?
Yes.
So means kind of 5 electrons will contribute electrons to these carbon radicals. Jadi siapa yang lagi stabil awak rasa? Yang ada satu R ke yang ada semua H?
1R.
1R. So if you compare with 1R and 2R, who do you think got more stable carbon radicals?
2R.
So these carbon radicals dia paling stabil ke antara semua?
Yes.
Okay, what do you say? By having this alkyl group, apa yang dia akan buat kepada your carbon radicals?
Donates the electrons.
Okay, the alkyl group will donate the electron, hence the carbon radical will become stable or not?
Yes.
Yes, so the carbon radical will become stable. Means you know you have this methyl primary, secondary and tertiary, and you know already that your carbon radicals is in electron deficit state. Therefore, by having this alkyl group attached to it, they are going to stabilize the carbon radicals. Kenapa kita kata alkyl group akan stabilize? Sebab alkyl group ni dia ada banyak elektron dekat dia. Bila dia banyak, dia boleh donate. So other name for alkyl group adalah electron donating group. Example of electron donating group adalah alkyl group. Electron donating group juga kadang-kadang diorang panggil electron releasing group. Means they are going to release electron towards this carbon radical. Okay, so kita tahu methyl primary, secondary, tertiary, siapa paling stabil, siapa yang paling kurang stabil?
Tertiary paling stabil.
Okay, siapa paling kurang stabil?
Methyl.
Methyl. So more stable radical akan formed from methyl to primary to secondary to tertiary. So by having more alkyl groups surrounds these carbon radicals means the stability will also increase. Okay, next species we have carbocation. So carbocation, they also got 4 classes. We have methyl, primary, secondary, and tertiary. Okay, so this carbocation is also an electron deficient species. But then, are they the same as in free radicals? Dia sama ke dengan free radicals walaupun dia electron deficient species?
No.
No, free radicals got 7 electrons surrounds the radical. Kalau carbocation, they got how many electrons surround this carbon? 6 electron, but somehow they are still in deficit state, right?
Yep.
Yes.
Ya, jadi yang saya nak tekankan kena hati-hati. Walaupun nanti awak tengok trend dia sama, tetapi when you are labeling the structure, if you use the radical ataupun dekat explanations ni awak tulis radical, tetap salah sebab awak tak fahamlah beza antara carbocation dan free radical. Walaupun explanation nanti sama. Kenapa saya nak cakap kat sini macam tu? Sebab nanti memang akan ada orang disalin balik apa benda ditulis kat free radical tu dekat part carbocation ke carboanion yang mana-mana yang sama. Jadi kena hati-hati dalam lukisan dan juga terms yang kita guna dalam explanations. Okay, since the carbocation is an electron deficient species, by having alkyl group, will they stabilize or destabilize the carbocation?
Stabilize.
Yeah, so the presence of alkyl group will stabilize the carbocation sebab dia samalah macam free radical tadi dia punya trend. Okay, means your most stable carbocation will be
Tertiary.
Tertiary.
okay. So having more alkyl group surrounds this carbocation means the stability will also increase. Okay, for the last intermediates of carbon, we have carboanion, where this carboanion also got 4 classes, but this time, this carboanion, it is an electron deficient or electron rich species.
Rich.
Rich. So carboanion adalah electron rich species. So the electron rich species now, this carbon got how many electrons surrounds it?
8.
8, but then kalau ikutkan dia punya valence electron masih 4 ke?
5.
5. Valence electron 1, 2, 3, 4, 5. Kalau ikutkan walaupun octet tapi dia banyaklah electrons kan dekat valence dia.
Yeah.
Sebab tu kita letak negative charge on
Yes.
this carbon. Okay, good. So, you know if you have this highly negative, if you keep on giving electrons towards it, will they become stable or unstable? Kalau dia dah negatif, kita bagi lagi negatif kepada dia. Dia jadi highly negative kan?
Yeah.
Yes.
So they become unstable. So what will happen? So what is the effect of having alkyl group surrounds these carboanion? Kalau kita ada,
Decreases the stability.
dia akan decrease the stability. In other words, they will destabilize the carboanion. So means kalau tadi kita ada the most stable is tertiary, in carboanion, will we still have the tertiary as the most stable?
No.
No.
This time kita akan kata siapa yang paling stable?
Methyl.
Methyl, followed by primary, followed by secondary, followed by tertiary. Sebab increasing number of alkyl group will only decrease the stability of carboanion. Therefore, more stable carbocation formed adalah ke arah methyl. Tertiary, secondary, primary and methyl. Okay. Okay, habis untuk part yang intermediate species. Now we move on to the third part where we have the species involved in any chemical reactions. Okay, from the reagents, we have 2 terms that you need to know. The nucleophile and also electrophile. Okay, so the nucleophile means the electron-rich species which can donate an electron pair to form a bond. So bila kita kata nucleophile ni, dia banyak elektron ke dia kurang elektron?
Banyak.
Bila dia banyak elektron, dia nak simpan ke dia nak bagi dia punya elektron tu?
Bagi.
Bila dia nak bagi dekat siapa? Dia akan bagi kepada nukleus. Kita faham nukleus kita ada positive charge juga kan?
Yeah.
So perkataan nucleophile ni comes from nucleus loving. Nucleo adalah nucleus, phile adalah loving. Itu maksud dia. So dia akan tertarik kepada nukleus, okay, yang more positive charge. Okay, so but then this nucleophile, walaupun dia suka yang positif tu, but it can be in either neutral or negatively charged lah. Dia mungkin dalam dia adalah neutral tapi dia banyak elektron dia. Macam kita belajar dulu antara lone pair dengan negative charge. Siapa yang lagi highly reactive? Kita kata negative charge sebab dia memang tak stabil. Tapi kalau neutral pun, kalau dia banyak elektron macam dalam water, dia still dikira nucleophile. Okay, awak akan jumpa nanti, bukan semestinya negative charge adalah nucleophile. Sometimes neutral compound pun adalah nucleophile. Dia yang akan do the bond attack atau bond attack tu. Okay, so example of nucleophile that you need to know adalah Lewis base. Lewis base kita ada dua jenis, sometimes anions, sometimes carboanions. Carboanions ni carbon with negative charge lah. Okay, bila ada je negative charge, confirm dia kaya dengan elektron, confirm dia nucleophile. Okay, another case, Lewis base adalah molecules with lone pair. So asalkan ada elektron tu, kiranya dia adalah Lewis base lah. And H3 we know we have one lone pair. Water we know we have two lone pairs. So this electron indicates they are rich in electron. And other example is when you have molecules that contains pi bond. Pi bond comes from the multiple bond. But the multiple bond that are capable to become nucleophile hanyalah between carbon and carbon. Kalau awak ada carbon dengan oksigen, itu bukan nucleophile. Sebab apa? When they have different electron activity, means the site of reactivity pun berbeza. Kalau you ada carbon dan carbon, dia akan sama, maksudnya dia distribute evenly. Jadi bukan semua pi bond adalah nucleophile. Kita tahu pi bond betul dia bawa elektron. Tetapi kalau ada carbon and carbon double bond sahaja, dia adalah nucleophile. Okay, when you have nucleophile means you're gonna have nucleophilic site as well. So saya dah cakap sikit tadi, apa beza antara nucleophile dengan nucleophilic site nucleophile dengan nucleophilic site. Nucleophile is the species. Nucleophilic site adalah tempat di mana reactions berlaku. Okay, since kita dah discuss pasal nucleophile and you have that in mind, yang nucleophile ni kena rich in electron. Okay, means in any compound, let's say in the same compound pun, awak boleh tentukan kadang-kadang bila dia connected by a bond, one end we have nucleophilic site, another end we have electrophilic site. It all depends. Kalau reactions tu berlaku dalam satu compound yang sama. Tetapi macam mana kita nak kenal yang sites of reactivity belongs to nucleophilic? They must have a lone pair on a heteroatom. Bila ada lone pair on heteroatom, it indicates that this atom is rich in electron. Jadi bila dia rich in electron, barulah dia boleh jadi basic dan juga nucleophilic. Nucleophilic adalah dia maksud kepada site of the reactivity. Nucleophile adalah species. So if let's say you are given this compound, you know NH3 they got 3 bonds with hydrogen, OH2 they got 2 bonds, and then apa lagi? OH minus they have this one single bond between O dengan H, and then Cl dia negative charge sahaja. Bila awak ada lone pair, confirm dia boleh jadi nucleophilic site. So kalau kita ada N dengan H, nucleophilic site dia pada N, bukannya pada H, bukannya pada bond between N dan H. Itu faham? Kan kita ada N, lepas tu kita ada bond 3H kan? Lepas tu kita ada lone pair kan?
Yeah.
Nucleophilic site tu kat mana? N ke H ke bond between N dengan H?
And
Dekat N sahaja. Ni adalah electrophilic site, nucleophilic site. Dalam satu compound yang sama, dia pun boleh ada electrophilic site yang kita akan jumpa nanti. Dalam kes ni, hydrogen adalah electrophilic site. Macam itulah. Kalau water, kita ada OH2. On this oxygen, we have 2 electrons, 2 lone pair. Jadi, antara OH bond ke O sahaja atau hidrogen sahaja yang akan jadi nucleophilic site? Kat mana nucleophilic site kita?
Kak O.
Kat O sahaja. Kalau antara OH minus, dekat O ke dekat OH punya bond?
O.
Dekat O sebab dia banyak elektron. Kalau Cl minus, dekat Cl minus je lah kan sebab dia ada salah satu dia je kan.
Yeah.
Yes.
Okay, so kalau dia minta awak tentukan kat mana nucleophilic site, awak kena bulatkan dekat tempat tu dan juga bagi tahu dia adalah nucleophilic site macam tu. Okay. Another case where we have this nucleophilic site is when these pi bonds, you have the pi bond yang kita cakap tadi, they will create the nucleophilic site. Maksud nucleophilic site kat sini apa benda? Okay, bukan dekat C bond C dengan H, tetapi atas bond ni sendiri. Kenapa kita kata atas bond ni? Dekat sini kita ada 2 elektron, dekat sini kita ada 4 elektron. So, 4 ni banyak kan daripada 2. Kalau compare to CH dengan CC je. CC betul lah. C dengan H baru 2 elektron je kan? C dengan H baru 2 elektron sahaja kan?
Yeah.
Kalau C dengan C berapa elektron?
4.
4. Jadi siapa yang sekarang ni rich in elektron?
C.
C dengan
C.
C. So kita boleh cakap dekat atas double bond itself, dia orang adalah nucleophilic site. Okay. And then another reagent yang kita akan kena tahu adalah electrophile. Electrophile ni adalah electron deficient species which accept an electron pair from a nucleophile. Okay, kalau kita relate kepada intermediate species 3 yang kita belajar tadi, who do you think gonna be the electrophile out of the 3? When we say they are electron deficient species.
H. What was the question?
Ya, next time kau tak faham soalan, tanya saya ulang. Jangan diam kan. The question is, out of the 3 intermediate species we have learned just now, who do you think gonna be the electrophile?
Carbocation.
Carbocation, the other one? We have 3 species altogether. Who do you think gonna be the electrophile apart from carbocation?
Free radicals.
Yeah, the free radicals. Thank you. So now, kenapa kena tahu benda tu? Sebab awak nak guna nanti benda yang sama juga. Kalau dia suruh determine who's going to be the electrophile, then you have to label them. If you simply learned about carbocation, carbonion, and then the free radicals, but then you don't know which one of those yang akan jadi electrophile or nucleophile, so tak berguna jugalah apa yang kita belajar tentang electron deficient ke electron rich tadi. So bila dia kata electron deficient, dia kurang dengan elektron. Bila dia kurang dengan elektron, they have the tendency to accept electron pair from the nucleophile. Tadi kita kata nucleophile ni electron rich ke electron deficient?
Electron rich.
Electron rich. So please bear in mind, in any reactions, nucleophile will always attack electrophile. Siapa akan attack siapa? Siapa yang always attack, nucleophile ke electrophile?
Nucleophile.
Yeah, only the nucleophile because they have the power untuk attack orang lain. Okay, so electrophile here means electron loving. Jadi dia akan susceptible to be attacked by the one that electron rich, iaitu nucleophile kita lah. Lagi. It can be either neutral or positively charged. Sama jugalah, dia bukanlah bila dia kata dia kurang elektron, dia kena positive charge tak. Sometimes neutral pun dia akan indicates they are electrophile. Okay, so example of electrophiles, they may come from Lewis acid such as AlCl3, FeCl3, Bf3, cation and carbocations. And then oxidizing agent Cl2 or Br2, kiranya semua ni adalah reagent yang awak akan guna dalam reactions nanti. And we have polar molecules. So polar molecules is also electron deficient species. Itu sahaja example untuk electrophile. And then for electrophilic site, since we have in mind electrophile means electron deficient, means this site is a hotspot for electron-rich species to attack. In other words, electron-rich species is the nucleophile. Okay, so bila kita kata dia nak kena attack, maksudnya around the polar bond yang kita ada, dia adalah kawasan yang low electron density. In other words, they are partially positive. So how do we indicate whether who's going to be the electrophilic site or nucleophilic site? Usually kita akan letak partially positive and partially negative on that particular atom. Okay, so usually they will involve the haloalkane, alcohol and carbonyl. Look on your haloalkane here. You have CH3, CH2 and Cl. Can you please tell me where is the polar bond present in haloalkane, between which atoms?
Chlorine and carbon.
Chlorine and carbon. So who will be the partially positive, who will be the partially negative between carbon and chlorine?
Carbon partially positive.
Okay, carbon partially positive, chlorine partially negative. What about carbon and OH bond? Siapa partially negative, siapa partially negative? Positive.
Carbon positive.
Okay, oxygen?
Negative.
Negative. And then we have here carbon
Negative.
double bond O. Okay, thank you. We have carbon double bond O. We know this double bond indicates there are so many electrons in it, right?
Yes.
Okay, but then the one yang kita acknowledge sebagai nucleophile hanyalah carbon double bond carbon, is it?
Yeah.
Yes.
Kalau kita ada carbon double bond oxygen, adakah kita akan tengok yang double bond dia sebagai nucleophile? Ke kita tak tengok dia pun? Double bond banyak elektron, tapi kat sini ke side kita?
No.
No, sebab dia bukan
No.
carbon double bond carbon tu. Okay, sebab sekarang ni carbon and oxygen got different electronegativity. Tapi reactions akan berlaku antara dia orang lah sebab dia orang adalah polar. Okay, so between carbon dengan oxygen, who's got more electronegative atom? O or carbon?
O.
Oh, okay. So kita kena denote siapa partially positive, siapa partially negative. Okay, now when we say electrophilic site, they will be attacked. Bila they will be attacked means they will be attacked by siapa? By nucleophile. So having nucleophile attacking the partially positive atom, which in all cases they are carbon, and then once nucleophile dah masuk, akan ada gangguan kan dari segi bilangan bond around this carbon, betul tak?
Betul.
Kalau kita tengok carbon asalnya dia ada bond dekat belah kiri, dia ada bond belah kanan dan dia dah ada dua hidrogen. Tiba-tiba sekejap lagi ada benda lain masuk. Kalau dia masuk dan tak berlaku apa-apa bond cleavage seterusnya, dia akan jadi unstable, right? Dia akan ada 5 bond, betul tak?
Betul. Betul.
Jadi in any reaction sebenarnya dia tak akan berlaku bond breaking sahaja. Dia tak akan berlaku bond forming sahaja. Dia akan berlaku serentak. Bond forming kat sini nucleophile masuk ke carbon dan juga bond breaking. Kalau dia tak berlaku bond forming and bond breaking at the same time, dia punya carbon akan jadi unstable. Bukan lagi carbocation, bukan lagi carbonion, bukan free radical. Totally unstable and totally totally wrong punya structure lah. Tak boleh carbon ada lebih pada 4 bond. Okay, so ni contohnya lah bila kata electrophilic site, kena ada partially positive, partially negative. Nucleophilic site pun sama. Okay, the last part of this chapter and also this subtopic called types of reactions. Okay, in organic chemistry, you're going to have 4 types of reactions. One is additions. We further breaks them into 2. Nucleophilic additions means nucleophile being added, and electrophilic additions means electrophile being added. Okay, nucleophile being added kepada siapa? Kepada electrophile. Electrophile being added to siapa? To nucleophile. Dia mesti ada dalam satu reaction tu, mesti satu nucleophile, satu electrophile. Okay, then we have eliminations. Eliminations simply you initially got multiple bonds. You initially got single bonds. Once you eliminate, they will become multiple bonds. Itu aim dia. You want to eliminate the bonds. Asalnya banyak, then jadi sikit. Daripada single bond jadi double bond. Daripada double bond jadi triple bond. Tu maksud eliminations. And then we have substitutions. Substitutions will involve all three species just now. Tetapi silap saya tak tambah sini. Ini patutnya electrophilic aromatic. Okay, electrophilic aromatic, bukan just electrophilic sahaja. Free radical substitutions, electrophilic aromatic substitutions dan nucleophilic substitutions. Means the free radicals will be substituted. Asalnya awak ada structure, awak masuk dia, tukar dengan benda lain. Kalau electrophilic aromatic substitution, nama dia aromatic berlaku pada aromatic compound sahaja dan dia akan substitute dengan electrophile. Nucleophilic substitutions, kita masukkan nucleophile, kita gantikan yang asalnya siapa yang akan keluar. Itu nucleophile being substituted. And lastly, we have rearrangement. Rearrangement pun saya cakap tadi, dia tak ada terbahagi kepada 3 ke 2. Dia simply rearrange sahaja, tak ada perubahan dari segi molecular formula. Okay, so for the first part, we have electrophilic additions. Electrophilic additions will involve only carbon-carbon double bond and carbon triple bond carbon. Okay, bila dia kata reactions involving carbon-carbon double bond and carbon-carbon triple bond ni, maksudnya kita sebut additions kan. Bila addition, nak tambah ke, nak buang ke, nak tukar ke, nak susun?
Tambah.
Tambah. Kita nak tambah pada siapa sekarang? Pada carbon backbone kan?
Yeah.
Okay, kita tahu carbon can have up to 4 bonds. Bila dia ada up to 4 bonds, boleh tak kita tambah lagi bond pada carbon yang dah ada 4 bond?
No.
No, sebab itulah dia kata electrophilic additions happen when you have only multiple bond. Maksud dia ada multiple bond ni, let's say kita padam one of the bond dekat sini. Okay, kalau awak tambah, bila awak tambah, dia akan melibatkan pecahnya satu bond ni. Bila dia pecah satu bond kan, dia pergilah buat reaction ke apa, dia akan dapat single bond balik. Yang double bond tu kita dah pecahkan, so dia hilang lah kan.
Betul.
So itu yang akan berlaku pada addition. Bila awak ada electrophilic additions, means you must have multiple bonds to start with. Okay, and then kenapa kita akan buat pada carbon-carbon multiple bond sahaja? Sebabnya dekat pi bonds ni kita tahu dia ada extra elektron. Dia ada extra elektron atas dan juga bawah. Jadi bila dia banyak elektron, dia bolehlah attack electrophile, betul tak?
Yes.
Sebab tu nama dia electrophilic addition. Electrophile being added to this carbon-carbon double bond. Bila being added, nanti adalah dapatlah single bond dan juga electrophile dah masuk. Tu maksud dia.
Okay, Miss.
Okay, so kita tengok example of electrophilic additions. You initially got your multiple bond and let's say you have this Br2. Dan this Br2, we know between this Br dengan C double bond C, this one gonna be the nucleophile or electrophile? Siapa akan jadi nucleophile? Alkene ke Br2?
Br2.
Kenapa awak kata Br2 jadi nucleophile? Ingat balik nucleophile punya ciri-ciri tadi?
Alkene.
Apa ciri-ciri nucleophile tadi? Nucleophile, nucleus. File, loving, dia suka pada yang lebih positif. Okay, saya faham kalau awak kata Br2 adalah nucleophile sebab awak kata Br kan banyak elektron. But now, between single bond and double bond, who's got more electrons in them?
Double bond.
Double bond. And then you want to perform this additions reaction. If you want to perform these additions reactions means you need to take one of these into this ni. Kita nak ambil satu Br ni masuk dalam ni kalau dia react dengan Br2. Untuk dia ambil, dia kena pecahkan double bond, right?
Yes.
Kalau dia nak pecahkan double bond, betul tak dia ni yang kena pergi attack untuk ambil? Bukannya dia ni yang pergi masuk baru dia pecah? Ni, electrophilic addition, electrophile yang kena add. Jadi kalau kita pecah dia ni, dia yang akan ditambah, right?
Yes.
Species yang ditambah kita panggil electrophile kan nucleophile dalam kes ni? Siapa yang kita nak tambah?
Electrophile.
Ya, jadi alkene akan jadi nucleophile. Br2 akan jadi
Electrophile.
electrophile. So bila nucleophile dengan electrophile, tadi saya cakap siapa yang akan attack? Who's going always attack? Nucleophile or electrophile?
Nucleophile.
Nucleophile. So we will break the bond between carbon and carbon. Bila dia break the bond between carbon and carbon, masih ada satu bond. So masih terikat. Dia ambil Br masuk. So kalau Br dia ambil masuk, dia tak akan ambil dua-dua. So dia akan pecahkan bond dekat sini lagi. Jadi last kali bila reactions berlaku, dia akan dapatlah structure macam ni. Okay, awak nampak dia ambil satu je ni, satu lagi dia tak ambil pun. Yang ni nak dapat benda ni, dia akan undergo a series of steps. Nanti awak belajar mekanism. Ni contoh dia lah, awak add dia. Sebab apa kita tak ambil satu je? Sebab dia melibatkan dua karbon kan?
Yes.
Bila awak ambil satu je, yang satu lagi tak stable, sebab tu dia ambil dua-dua. Bila dia melibatkan dua karbon, dua-dua akan masuk. Kalau dia melibatkan satu karbon je, mungkin dia akan substitute sahaja. Okay. Next, we have nucleophilic addition. Who's being added? Nucleophile or electrophile kalau nama ni? Nucleophile yang kita akan tambah. Tambah ke mana? Tambah ke electrophile. Okay, jadi nucleophilic additions usually takes place in aldehyde or ketone. Can I know the functional group present in aldehydes and ketones? What is the name of your functional group present in aldehyde and ketone?
Carbonyl.
Carbonyl. Carbonyl is characterized by carbon double bond O. So ada carbon double bond O, boleh tak nucleophilic additions berlaku? Kalau ada carbon double bond O, maksudnya nucleophilic addition boleh berlaku ke tidak?
Boleh, Miss.
Boleh. Okay, good. Sebab apa? Kita nak tengoklah sebab tadi awak dah belajar site, electrophilic site, nucleophilic site tu. Bila nucleophilic additions berlaku, maksudnya kalau dia berlaku pada aldehyde dan ketone ni akan jadi the electrophilic site awak. Dia akan being attack. So nucleophile yang highly negative ke ataupun any neutral yang ada banyak elektron tu will approach the electrophilic carbon of the carbonyl group. Kan kita buat tadi, carbon dengan double bond O, diorang tak sama electronegativity. Jadi yang partially positive tu akan jadi electrophilic site. Okay, if we look at this example, we have cyano group and also this one is ketone or aldehyde?
Ketone.
Ketone. Is ketone. Okay, good. Sebab dia ada carbon kepit dia. Okay, now between these two, siapa akan jadi nucleophile? Cn minus or ketone yang akan jadi nucleophile. Yang akan attack. Siapa yang akan attack?
Nucleophile.
Ketone.
Ketone.
Ketone. Awak tengok betul-betul Betul kita ada banyak elektron kat sini. Kita pun banyak elektron. Tapi kita kata tadi, when you have carbon multiple bond with oxygen, they are no longer nucleophile. Means they are going to form, bila kita ada share bond between partially positive and partially negative, maksudnya yang kaya dengan elektron adalah O, bukannya the double bond. So this carbon will immediately become the electrophilic site. Bila dia ada electrophilic site, maksudnya dia akan jadi electrophile ke nucleophile?
Electrophile.
Ya, maksudnya Cn minus adalah nucleophile. Awak memang kena tentukan siapa nucleophile atau electrophile. Kalau tak, awak takkan betul pun buat reaction nanti. Arrow ke arah siapa. Sebab tu nanti arrow tiba-tiba nucleophile bawa keluar dua-dua arrow. Padahal satu sahaja. Okay, so this nucleophile will attack carbon or oxygen. The electrophilic site kat mana? Carbon ke oxygen?
Carbon.
The carbon. They will attack this carbon with partially positive, and then the bond between carbon and oxygen, one of them will breaks. Bila dia breaks, okay, dia akan form negative charge. But once they undergo a series of steps, dia akan masukkan hydrogen pula. So kita akan dapat cyano and also OH group dekat sini lah. Dia adalah a series of steps dia. Walaupun dia breaks ni kita tahu O negative je, nanti dia akan ambil hydrogen pula. Dapatlah hydrogen tu daripada reagent yang kita akan guna dalam, ini adalah chapter aldehyde and ketone. Okay, then we have eliminations. Eliminations, our aim is initially you eliminate. Maksudnya you nak tambah ke nak buang?
Buang.
Buang. So
Nak
dia
buang.
the opposite to addition. Kalau addition, electrophilic addition tadi kita start dengan single bond, right?
Yes.
Single bond pula, sorry, multiple
Double
bond.
bond.
Yes. Kalau eliminate daripada single nak jadi
Double.
double bond. Okay, so the opposite sahaja. Okay, daripada single reactant nak split into two products. So kita nak form double or triple bonds lah. So you initially got this structure, this compound ni kita ada all single bonds. Once we eliminate, bila sebut eliminate and we want to form double or triple bonds, dia akan involve two carbons or only one carbon? Berapa banyak carbon terlibat dalam elimination ni? Kalau kita nak form double or triple bond ni?
2.
Two, maksudnya akan keluar Br sahaja ke akan keluar H dan Br?
H dan Br.
Bila dia keluar H dan Br, dia dapat double or triple bond?
Double.
Double bond. Okay, macam itulah. So selalunya kalau dalam eliminations, kita nak remove small molecules. Okay, dalam tadi tu kita tak adalah tak adalah nucleophile or electrophile sebab dia just eliminate. Okay, next we have free radical substitutions. Means substitutions kita nak ganti. Kita bukan buang, kita bukan tambah, kita nak ganti. Asalnya awak ada 4 bond keliling carbon. Once substitutions happen pun 4 bond. Tetapi substitution sekarang siapa yang terlibat? Free radicals. Bila free radicals, somehow you will still need to use the half-headed arrow, the homolytic cleavage with the presence of UV. Okay, so free radical substitutions takes place in alkane. Kenapa alkane? Alkane ada single bond je kan?
Yes.
Dan dia tak ada heteroatoms yang ada dia ada heteroatoms. Dia tak ada heteroatoms yang ada two different electronegativities. Sebab kita tahu free radicals is formed from homolytic cleavage. Homolytic cleavage takes place between non-polar bonds. Sebab tu dia kata berlaku dalam alkane. Okay, conditions yang kena ada adalah light. Sunlight ke, UV ke, HV or just light pun diterima. Okay, you have this compound, tak kisahlah ada lagi banyak carbon pun tak ada masalah, tapi tempat yang kita nak tukar hanyalah satu. Dia depends lah antara C dengan C ke C dengan H, depend pada structure tu. And then we have this Cl2 with the presence of light. Only with the presence of light, these free radical substitutions will take place. Okay, jadi apa yang dia akan buat, dia akan undergo homolytic cleavage dekat sini dan dekat sini juga. Okay, apa yang akan berlaku? Tadi kita buat seorang dia je. Sekarang ni H ni akan pergi bergabung dengan Cl. Bila dia pergi pair up dengan Cl, dia akan dapat bond between H dengan Cl pula kan? Ni dengan ni jumpa dapat H dengan Cl. What happened to this Cl? Cl akan jadi free radical, C pun akan jadi free radical. Boleh tak dia orang pun bergabung?
Boleh.
Boleh. So nanti awak dapatlah structure baru. Berlakulah substitutions dekat sini yang melibatkan free radicals intermediates dia. Okay, then we have nucleophilic substitutions, means nucleophile is substituted. Okay, berlaku selalunya pada haloalkane. Haloalkane ni when you have carbon attached to it, we have the halogen. When you have carbon and halogen attached to one another, dia punya difference in electronegativity tu tinggi. Jadi senang untuk reactions berlaku. Maksudnya you nak remove Cl ke Br ke senang sebab different in terms of electronegativity dia orang tinggi. Okay, so basically nucleophile will approach the electrophilic carbon on the haloalkane. Bila kita kata electrophilic ni, dia site ke species?
Side.
Site, okay. So dekat mana site tu? Atas haloalkane. So antara diorang siapa nucleophile, siapa electrophile? OH or haloalkane dan nucleophile?
Haloalkane.
Siapa nucleophile? OH or haloalkane?
OH.
OH. Tadi awak cakap haloalkane, awak tengok ni. Kat sini dia dah bagi dah hint. Electrophilic carbon of haloalkane. Bila species tu ada electrophilic site, semestinya dia adalah apa?
Electrophile.
Yeah, so nucleophile is the one with more negative charge tu. Electrophile adalah yang ada kes-kes macam ni lah. Awak ada polar bond, dia lebih positif, dia lebih negatif. Awak kena compare between these two. Siapa yang lebih negatif akan jadi nucleophile. Siapa yang kurang negatif akan jadi electrophile. So OH minus will attack the carbon or the Br. OH minus as the nucleophile is prone to electrophilic site or nucleophilic site?
Carbon.
The carbon as the electrophilic site. Jadi dia akan attack dekat carbon and carbon BR bond akan breaks. Once they broken, apa jadi? Adakah C tu akan jadi carbocation ke dia terus jadi compound lain? Kalau OH masuk, dia electron deficient ke carbon ni? Kalau OH masuk, yang ni pecah keluar.
No.
Kalau OH masuk ke carbon, dia akan form a bond kan?
Yes.
So dia jadi extra dah 5, tak boleh. So kena breaks the bond between C dengan BR. Saya tanya, carbon awak yang bila dah terima OH ni, dia masih jadi electron deficient ke? Dia bukan electron deficient, dia dah jadi compound yang stable.
Jadi compound yang stable.
Ya, jadi compound yang stable sebab kat sini kita berlaku substitution. Jadi masuk terus keluar, terus dia tukar kat sini. So dapatlah instead of BR kita akan masukkan OH. BR akan keluar. Then we have this electrophilic aromatic substitutions. Tak ada pun electrophilic substitution sahaja. Dia mesti electrophilic aromatic substitutions means they will involve on the aromatic ring. You will learn more thoroughly about this mechanism in chapter 6, benzene and its derivative. So electrophilic aromatic substitutions takes place in all aromatic compounds. So basically benzene. So since this benzene has 6p electrons, they delocalize in the 6p orbitals. Dia ada atas dan bawah membuatkan diorang ni electron rich. So bila electron rich, dia ni akan jadi nucleophile or electrophile, the benzene itself.
Nucleophile.
Benzene will become the nucleophile, means Br2 akan jadi. Nampak ni, dia kena attack kan? Kalau dia kena attack, dia ni siapa? Electrophile ke nucleophile?
Electrophile.
Ya, electrophile. Sebab apa? Benzene ni kita tahu dia ada carbon-carbon double bond dan dia ada delocalize. Bila sebut delocalize, dia punya elektron lagi kuat daripada yang single bond, yang carbon-carbon double bond open chain. Okay, so nampak je benzene tahu dia nucleophile. Dia yang akan attack, bukan diorang ni yang attack dia. So, apa yang dia buat sekarang, dia akan ambil the BR, dia akan tukarkan dengan hidrogen dekat sini. So nanti dapatlah this benzene with bromine on it. So we call them as bromobenzene. Ini adalah catalyst. Bila catalyst, diorang digunakan dalam reactions ke tak? Will they be consumed or they just aid the reaction? Aid, okay. Lastly, okay, last one untuk malam ni. Eloklah lagi 4 minit. Rearrangement. Okay, rearrangement, you simply rearrange them without changing the molecular formula. So initially you have single reactants, then they undergo reorganizations of bonds and atoms sahaja. Okay, so macam ni lah contoh dia. Awak ada berapa carbon? 1, 2, 3, 4. Means, once they undergo reaction sekalipun, kalau dia rearrangement, bilangan carbon tetap sama. 1, 2, 3, 4. Okay, H pun sama. 3, 4, 5, 6, 8, 9. 1, 2, 3, 4, 5, 6, 8, 9. So, under the presence of acid catalyst, they akan rearrange. Okay, since we have this carbon-carbon double bond, can I know whether this reactant on the left is considered cis-trans isomer or not?
No.
No, sebab do they have the restricted rotations of carbon-carbon bonds?
No.
Do they have restricted rotations of carbon-carbon bond as the first features of cis-trans isomer?
Yes.
Yes, they have the restricted carbon-carbon bond due to alkene, right?
Yes.
Okay, first feature dia obey. Then second feature dia obey tak? Each carbon holds 2 different atoms or 2 different group of atoms.
No.
No, so dia bukanlah cis-trans isomer. Tapi once they rearrange, is this considered as cis-trans isomer?
Yes.
To be specific, this is cis or trans?
Trans.
Trans, because we have CH3 on different side now. Okay, tu sahaja, habislah.
Okay, Miss.
Alright, okay, thank you everyone for tonight's class.